Hello, this is Khatami with SCS Engineers. The subject of this presentation is landfill leachate collection pipe design. The purpose of the presentation is to introduce an innovative design for leachate collection pipes that can potentially reduce or eliminate the likelihood of clogging in the vicinity of the pipe. There will be several discussions taking place throughout this presentation. We begin with a discussion on the clogging of leachate collection pipes and whereabout this clogging normally happens. The second discussion would be presenting a traditional design of leachate collection pipes. A CAD drawing of the traditional design will be presented to you, and a discussion of the flow path of leachate from the leachate collection system at the base of the landfill to the leachate collection pipe will take place. After that, we'll have an introduction of the innovative design of leachate collection pipe. CAD drawings will be presented to you to show the details of the design, as well as a discussion on the flow path of leachate from the leachate collection system at the base to the pipe for this innovative design. Toward the end of the presentation, we'll have a number of photos that we want to share with you from a recent construction event that this innovative design was implemented successfully. Clogging issue in reference to the subject of this presentation, which is leachate collection pipes. In general, when large quantities of leachate pass through a small area of textile, it can potentially cause clogging in a rapid manner. What it means is that clogging reduces flow of leachate through textile. In reference to the leachate collection pipes, if there is a textile on the two sides of the leachate collection pipe in the system, and large quantities of leachate from the base area has to pass through this textile to get into the gravel and the pipe, it can potentially create clogging at the textile and impede free flow of leachate from the base into the pipe. Before we continue with the subject of clogging, I would like to present to you a simple rule that I refer to it as a rule of transmissivities. Leachate must always flow from a transmissive medium into another medium with equal or greater transmissivity. What it means is that if in the path of leachate flow, leachate is coming out of one medium and going into a second medium, the transmissivity of the second medium should be equal or greater than the transmissivity of the first one. And if that rule is not followed, then the system may experience a bottleneck in the flow direction, and that bottleneck can potentially create clogging in the system. Now we continue the subject of clogging in reference to the leachate collection pipes. This is a presentation of a traditional design of leachate collection pipes. I grabbed this from one of my designs, and I would ask that if you would please ignore the type of the lining system presented here. That is not the subject of this presentation. The type of lining system here is a double composite, but I would like to bring your attention to the middle portion of this detail, which is a leachate collection pipe encased in gravel, and the gravel is wrapped with geotextile. Below the geotextile wrap is the composite, which is a primary leachate collection system in the leachate trench, as well as the base area. I would like you to envision the flow of leachate through the composite getting into the leachate trench, which in this drawing also refers to it as LDS soil, but I will be using leachate trench throughout this presentation. The water in the composite in order to get to the pipe, would have to come out of the geonet through the upper geotextile component of the composite, pass through the geotextile wrap to enter the gravel, and from the gravel to the pipe. If you think back of the rule of transmissivities, the flow of liquid out of the geonet through the upper layer of geotextile doesn't meet the rule of transmissivities. In the next slide, I'm going to go step by step to show you from what medium to what medium the leachate flows, and we get more into the details of it. Here is the flow path of leachate in the traditional design. Leachate moves from waste to the sand layer, which is above the lining system. Normally sand layer has a higher permeability than waste, so it's a check mark. It follows the rule of transmissivities. Then it moves from the sand layer to the upper geotextile of the composite. Again, upper geotextile of the geocomposite has higher transmissivity than sand layer. Again, it meets the rule of transmissivities. Then leachate flows from the upper geotextile to the geonet component of the geocomposite. Again, geonet transmissivity is higher than geotextile. A check mark, it meets the rule of transmissivities. Then when it comes into the leachate trench, leachate must flow from geonet through the upper geotextile of the geocomposite. In this case, upper geotextile of the geocomposite has lower transmissivity than the geonet, so it does not meet the rule of transmissivities. We just continue on the path of leachate, then it goes from the upper geotextile of geocomposite to geotextile around gravel. These are equal transmissivities, so it's a check mark, it meets the rule of transmissivities. Then it moves from the textile wrap around the gravel into the gravel. Gravel transmissivity is higher than the textile, so it's a check mark, it meets the rule of transmissivity. And finally it moves, leachate flows from gravel to the pipe. Pipe transmissivity is larger than gravel, so it's a check mark, it meets the rule of transmissivity. But in general, the whole flow path does not satisfy the rule of transmissivity because of the item number 4, that is the cross mark not meeting the rule of transmissivities. So there's a potential of clogging at that interface from the geonet to geotextile of the geocomposite, which could potentially impede free flow of leachate from the leachate collection system into the pipe at some point. Solution. What is the solution to this to the problem with the traditional design? The solution is eliminate geotextile. I'll explain to you what I mean by eliminating geotextile. The innovative design for the leachate collection pipe is presented in its detail. Again, I would ask you to ignore the type of lining system. It's basically still a trench in the middle, and the geocomposite coming from both sides into the trench brings leachate toward the leachate trench. In this case, we still have pipe encased in gravel, and the gravel is covered with textile. But before I get to that textile, I would like to bring your attention a little bit further down in that detail to the primary geomembrane, which is a solid dark line below the pipe. Directly above the geomembrane, there is a dashed line which represents a geotextile cushion, and then above the textile there is a geonet. The textile and the geonet both act as cushion to protect the geomembrane against the gravel that goes above the geonet. As presented here, gravel goes directly on top of geonet. What it means that there will be no geotextile going under the gravel to enclose or encase the gravel entirely into textile. Then it goes the pipe and the gravel above the pipe, and then the textile above the gravel. I would like to bring your attention to the right and left sides of that textile. It gets sewn to the upper geotextile component of the composite on the two sides. And you may have already noticed that the composite extending from the base area into the trench doesn't go below the pipe, it terminates somewhere in the trench, and the geotextile above the gravel gets sewn to the geocomposite on two sides. Now, if you envision the flow of leachate from the base area in the composite coming to the trench, you will notice that the liquid in the geocomposite goes directly from the geonet into the gravel, which in a sense meets the rule of transmissivities. Gravel has higher transmissivity than the geonet, and there's no geotextile between the geonet and the gravel to not follow that rule and to potentially cause clogging. Now in the next slide I'm going to take you through every step of the flow of leachate in reference to this innovative design for you to see the details, how every component of it meets the rule of transmissivities. Here is the flow path of leachate in an innovative design. Leachate flows from waste to the sand layer. Again, the transmissivity of the sand layer is normally higher than the waste, so a check mark meets the rule of transmissivities. Then leachate flows from the sand layer to the upper geotextile component of the geocomposite. Geotextile has higher transmissivity than the sand layer. A check mark meets the rule of transmissivities. Then from the upper geotextile, leachate flows to the geonet component of the geocomposite. Geonet has a higher transmissivity than geotextile. Is a check mark, it meets the rule of transmissivities. Then leachate flows from the geonet to gravel, as I presented to you on the detail. Gravel has a higher transmissivity than geonet. A check mark meets the rule of transmissivities. Then the last step, leachate flows from gravel to pipe. Pipe has a higher transmissivity than gravel. Check mark meets the rule of transmissivity. So the whole flow path presented here in the innovative design follows the rule of transmissivities, and the potential for bottleneck in the flow path gets eliminated, and the potential for clogging gets eliminated just because we eliminated the geotextile that could cause the clogging problem. Now we go through the photos of a construction event during which an innovative design was implemented. We start with this photo that showed the geomembrane at the base and through the trench. For a moment, just ignore the background and just pay attention to the front, that the geomembrane is laid out, deployed, and the next step is to install the geocomposite. Geocomposite is installed in this picture to the right and to the left side of the trench. As you see in the picture, the geocomposite doesn't extend through the trench as we discussed during the detail. It gets terminated somewhere in the trench in order to tie into other components that gets installed next. Then it's time to install the geotextile cushion directly above the geomembrane. And it could be a panel-wide geotextile or somewhere narrower than a panel-wide geotextile, depending on the size of the pipe gravel burrito that will be sitting on top of it. After the geotextile is deployed, then geonet gets deployed. As I discussed earlier, both geonet and geotextile act as cushion in order to protect the geomembrane underneath from the gravel that goes directly on top of the geonet. Geonet prevents larger particles of gravel to reach the geomembrane, and geotextile prevents smaller pieces that may exist in the gravel pack to reach the geomembrane. This picture shows the final stage, that the geocomposite on both sides of the trench are tied to the geonet that was shown in the previous slide. They're all tied together with plastic ties. So in a sense, the trench is ready for gravel at this stage. Gravel placement begins. We normally place 3 inches of gravel below the pipe. So in this case, the 3-inch thick layer of gravel is already placed on the geonet. And the next step is to pull the perforated pipe over the 3-inch thick layer of gravel. Here it shows the pipe is sitting on top of gravel, and gravel is directly above the geonet. And on the 2 sides, the geonet is tied to the composite, which is tied to the geonet component of the composite. And if you look closely on the upper part of the slide, the upper geotextile of the composite is peeled back because we want loose geotextile at that point in order to be sewn to the textile that covers the gravel. It shows the pipe sitting on top of the 3-inch thick layer of gravel, and to the left side you see the textile that is will be pulled over the final stage of gravel after the gravel placement is complete. Here is the gravel placement above the pipe is in progress. The textile that will be pulled over the gravel is sitting on the left side, and when gravel placement, shaping and forming of gravel is completed, the textile gets pulled over it. Here it shows the gravel is already placed above the pipe, shaped and formed, and the next step is to pull the textile over gravel. Now the textile is pulled over gravel, held in place with sandbags until the installer gets to sew the textile to the upper geotextile component of the geocomposite on each side. Here they are sewing the textile to the upper geotextile component of the geocomposite on one side of the gravel pack, and then they'll move on to the other side to finish the work on the other side. It shows in the foreground of the slide the geotextile is already in place and sewn on both sides to the upper geotextile component of the geocomposite, and then the latter part of the gravel, which is exposed, will be covered later. It's a completed work. Gravel is in place, geotextile is pulled over it and sewn to the upper geotextile component of the composite on the 2 sides of the trench. The next step is to cover this gravel pack with the sand layer that goes above the lining system. At this stage, we specifically ask the contractor to work closely with us and not simply push sand over the gravel pack, because the act of pushing sand over the gravel may disturb the gravel. That by itself could cause problem in terms of the integrity of the pipe in the long run under the high compressive loads of the waste. And on top of that, the geotextile may get disturbed. That protects the gravel against fine particles from the sand layer. So in a sense, we ask the contractor to scoop up sand and directly at a short vertical height above the burrito, place it on top of burrito. After the sand is placed over the burrito in a very careful manner and protection is in place, then they come in and push sand against that and grade that area to whatever needs to be graded to. Here it shows the completed cell. Again, in this case, it was a 12.5 acre cell. If you look closely, you will see the 2 lines which represent 2 leachate lines One is closer to you and one further back. These are the leachate collection pipes that were constructed in this project. This is the same cell, but the middle portion of the cell after completing the cell. And this is the upper portion of the cell with the sand covering the entire lining system. I thank you for your time, for listening to this presentation. I hope this presentation becomes useful to you for your future designs in order to eliminate clogging at a very critical point near the leachate collection pipes. If you have any questions, please feel free to contact me via my email or my cell number 561-441-1473.